This is just a test code where you are seeing how we can use the ROS2 infrastructure. So here in this command, add robot x30 means whatever is the x position of the robot, I don't know, but I want to add on top of that x equal to x plus 30 kind of. Enter. It is trying to process, and see the ball or the robot moved in x coordinate, and you see the value in the. Hello friends, in this video we are going to discuss about ROS2. So I have a practical example of ROS2. ROS2 means robot operating system, and 2 is the latest version. I mean, under that there are many names, so I'm working with Jazzy Jalisco. But the point what ROS2 brings us and what is the topic of this video. So here in this video I want to show how using ROS2 we can connect we can connect with Arduino Uno and collect multiple data. Suppose the Arduino Uno is connected with multiple sensors. It's connected with a real-time robot who is moving around the floor, and you want to control using ROS2. But that could have been done by easy way, right? Like using a remote control program using Python or any just a physical remote control. You could have anyway run the robot. But why you want to use ROS2 for that? The answer here is like if it is slowly going to be complicated, like suppose you want to create a floor planning robot like the vacuum cleaner, but this moving left and right is just a piece of it. I mean, it's not the main project you're looking for. You're just first making a robot that can move around, and then on top of that base code, whatever you write just for the base, I mean just to move around. On top of that, you want to write further the mathematics, how to find out the different locations and floor planning, LiDAR data and all these things. So if you want to do this kind of thing, if you are every time looking for left, right and all these things, you will be stuck on the very boilerplate code. I mean the basic left and right that itself will engage you for a long time. You cannot make a progress. But using ROS2 we can create a nice abstraction layer. What is the abstraction layer? Suppose you have a code already written, move forward, then move backward, then left, right, all these things. The code is already written, and then you don't want to write it again. On top of that, you are creating another layer where using them you want to achieve something bigger. What is something bigger? You want to say move 10 centimeter, move 10 centimeter, or say turn 30 degree. Turn 30 degree. So how can you do that? Turn 30 degree means while turning left you can have a timer how long you are turning, or maybe some other sensor. So you can have some very complicated code or whatever code it is to implement or taking care of that. But at this point, sitting at this layer, you are not really bothered about how it is being implemented, because those are the basic, I mean the root level code, the boilerplate code, whatever you say. So when you are working on this level, you are not actually talking about that. So this is called abstraction. So you are abstracting the complexity and slowly moving to the higher level. So once you know how to do moving forward, turning left and right, on top of that you can write more complicated logic like sine theta, cos theta kind of thing. Like a floor plan robot is moving left and right, and a LiDAR sitting on the top of it is keep sending you some distance data with some angle. Now you have to plot that real time into some 3D graphics and plot the whole house floor. So how can you do that? So for that you cannot really work with this kind of things. You have to really work hard on the mathematics part. So those kind of abstraction is given by ROS2. So if I tell in very top level how a ROS2 works, it is like the ROS2 infrastructure. It gives a publisher subscriber module. I mean you can create a code in C++ or Python mostly used. So supposing for example I have used Python. So Python code who is a publisher or subscriber. So this guy will broadcast, I am my name is get location xy or get xy. And how he will get xy? This Python is actually coming out of the machine and through the UART port connected with this Arduino that you are seeing in the video, and he's pulling the data of xy and giving it to whoever wants it. So he is just the get xy. So that means sitting in this kind of framework. From anywhere, if I call get xy, whoever the client is, if he subscribed to this get xy, he will be keep getting the xy location of the robot. And similarly, set xy will help you to move the robot any direction. So after you do that complicated sine theta, cos theta, and finally end up with some value that you want to move the car to, and then you just send a set xy, and you don't have to bother about how that is implemented. In future, if this Arduino is gone and some other device comes like ESP32 or something else, your code will not change. This get xy, the topic who is actually serving this, the code inside that will alone change and nobody else will change, and that's the beauty of ROS2. So this publisher subscriber, like this, if you are subscribed to this get xy, you will be keep getting. If you subscribe to the topic set xy and keep sending the command to move here and there, and this all together will give you some output. For the floor mapping case, you also might need, along with the get xy, you might need a theta, or maybe I could say r theta instead of xy coordinate. You can go the polar coordinate, so whatever it is. So this is the top point. So let's see some demo. I have flushed the simple Arduino UART code for this Arduino. So this is the code running currently into the Arduino. So this is the code, just a simple code. It is even if you're asking for get temperature, see there is no sensor connected. I'm just sending a random value. This is just to prove the concept that if a real sensor is connected, it is really capable of sending you the real data. Currently I'm not bothered about that, so I'm just sending a dummy value back. So once this code is running in this, and we want to see how using ROS we can see, visualize, and play with it. So for that, I have installed WSL. WSL means Windows subsystem for Linux. Okay, so this Windows subsystem for Linux, I mean, this is the one if you see in the Google, and this is a very powerful thing where in Windows itself you can install Linux, because Linux is recommended for ROS2, because ROS2 has a very nice and big community. If you want to make use of all the things they have, you must use Linux, because there is a Windows version, but that is not very capable of doing all the things. But for the bare minimum thing we are doing here, we can very well create a Python code and we can skip the ROS2, but that's not the topic. I want to show how to be in the ROS2's ecosystem and achieve things, so that in future you can scale more. So given that, let's open the PowerShell. So how to activate the so there are multiple hurdles. So once I connect the Arduino with my computer, now the next thing is I will see how can I connect it with our ROS2. So for that, I'll go to the device manager. So if I open this device manager, and then here you can see in the port my Arduino is connected at COM22. So this COM22 port I have to use from the Linux. So I cannot use it out of the box, because Linux is very secure and they don't allow external devices to be just to be connected with any device, or any program can be directly accessed with any program can directly access any port without any admin privilege. No, that's not allowed by Linux. So for that, I will open PowerShell in admin mode, and I have to bind the port. So for binding the port, before binding the port, I want to see the command I have to run USB ID and see what are the USBs available, and I know this is the one, and this is the bus ID 5-1. It can be different for you. So now I want to bind it. So for binding, I will use the command I'm just copying from another place where I have created all the document, and so this is the 5-1 what I'm looking for. So I will just bind it. This binding helps to make this device a shared device. So you see there is no shared device in the USB terminal. That's all right. Now once I press enter, you will see this device will be gone from the top, and he will be a part of the shared device, USB IP shared device. So that's now if you are searching for this list and it is there, but it's as a shared and forcefully shared device. Okay, so now it is shared, and now next is we have to give this we have to attach this shared device with our WSL Linux. So I have installed the Ubuntu in Linux and installed the ROS2 in the Linux. So if I attach this, it will say error. Why? Because I don't have a WSL running in another folder, in another terminal. So what I will do is I will go to a folder where I have all the Python code that I want to run from WSL, because WSL is a Linux kernel, but the hard disk and all is actually used from Windows. So if you are in a Windows folder, and you can use the file from Windows and run in the WSL in Linux. So for this I will do PowerShell, and if you type PowerShell in the address bar, it will open a PowerShell window in the same path where I have all the files that I want to use. So given that, now one of the WSL is running. Now this code will not fail. This command will not fail. It's still failing. Why? So sorry. So this is, I'm not yet logged into Linux. So for that I have to type WSL, enter, and first time it's taking time because none of the WSL consoles are running, so probably it is booting up the Ubuntu. Come on. Yeah, it's on. Now I will run this, and yeah, so it's connected. Okay, so it's connected now. Now this port is accessible from Linux. So now this WSL running Ubuntu can access the physical port of Arduino. So I'm just forwarding the port from my Windows up to the WSL. Now I have the code to be run here, and for that to work, before that I have to give access privilege to the user. I have a user created on my name. I have to give access privilege to use this USB device by login from the user. So this user, I have to give the password to give the admin privilege, sudo, and then for ROS2 environment variable to be available or accessible from the Linux, you have to always enter this, or you can write it in a place where it is always any terminal will launch with this, but yeah, that you can do later. And this one is optional, like because you are already in that folder. But if suppose you are in a different folder in Windows, you can anywhere you can mount. Anywhere you can go just by giving the right path, mount, and then this is D drive. So from D drive, so I'm already there. Now you see in this folder there are two Python file. So one file is for bridging. Bridging means this is what I was explaining in the paint. I did it. So this is the Python code who is actually broadcasting the topic, and he is actually the bridge between Arduino and our Ubuntu or our machine, our system. And we have to open another terminal from where we have to subscribe. So this is one terminal, okay? This is one PowerShell terminal where this bridge is running. We have to open one more Ubuntu terminal where we have to subscribe to this and create a UI console. Not a GUI, where we want to see it physically where this robot is in the floor. And then we will create one more PowerShell, and here we will give command for the robot to move left, move right, and we will see this robot is physically moving. In our case, the simulate, you cannot see it moving, but you can see the data coming in here. Data will be coming here because this UI will keep polling, or it has subscribed to the get command, get xy. This is because to draw something in the right place in the frame, you have to know every millisecond or whatever is the refresh rate. You have to keep asking for what is the xy, because you understand this is I can connect another device with this Arduino or the robot, and from that robot also I can command, from that console also I can command him to move. So the ground truth may not be anywhere else, but the data coming from here. This is the ground truth, this is the reality. So if anybody else also giving him command to move, like the multiplayer game, that data also will be consolidated here, and final data will come to this. So he will know the ground truth, and you have to keep asking him. You cannot assume. I mean, what I mean to say is, you are sending command from here. You could have directly connected from here and get the XY right instead of asking him, because you know this. But he may not be the only client. There may be many other clients asking for commands from him. While he is moving the robot, he might be asking get temperature. And if both are asking for move, then you don't know whom to subscribe, whom to directly sync with. So this kind of abstraction is very important or helpful, and that the ROS2 is giving us. So okay, coming back. So now this UI we have to launch, and this command thing we have to launch. So this 2 more PowerShell we have to launch. Before that, let's finish this one. So we have to run the bridge code. Now this bridge code is running means we already got connected with the Arduino. Okay, so Arduino is connected, you see, connected to the Arduino, and the device name is not com whatever you saw, 20 or what. In the Linux the name is little different, deb tty acm whatever. So that's it, that it is. And now I have to open one more PowerShell. So I'll just click my mouse scroll to open another PowerShell window. Let it be anywhere, because anyway I will bring it there. So now next one, here I will again start WSL and initialize the environment variable, and this time I will really move to the folder because I opened it from anywhere, and now I am actually in that Python WSL folder. And now I will run the other Python code, which is called robot visualizer. So now once I run that, let me copy one more time. If you right click, it will just copy, and then if you run, you will see a pop-up window, and you see this guy keep sending the data. I mean, keep printing this value. Why? Because this guy has subscribed to him, and he's asking give me data, keep giving data. And what is the refresh rate and all is written in the code. So the codes are available in GitHub. You can collect it from the description. I'll not spend time on that, but what I'll do is I'll keep all these things back to back, and along with the locations. And next, another console, another PowerShell, and in this PowerShell I have to give the commands, right? So again WSL. So I'm logging into the Linux from 3 different console, same Linux Ubuntu, and setting up the initial the environment variable. And now this is all the this is the main thing where what you will finally send. So this is just a dummy send command, and instead of that you can programmatically ask him to move, and that is the final thing you will be doing, because after calculating sine theta cos theta, and you are not going to send by typing. This is just a test code where you are seeing how we can use the ROS2 infrastructure. So here in this command, add robot x30 means whatever is the x position of the robot, I don't know, but I want to add on top of that x equal to x plus 30 kind of. Enter. It is trying to process, and see the ball or the robot moved in x coordinate, and you see the value in the bridge Python. It is showing 30 for x and y is 0. So the same thing, if I send one more time 30 and now 10, so 30 plus 10, it will be 40. So let's see, it's 40 here. But now if I use instead of add, if I use set, then set 10 means it will set back to x equal to 10, not x equal to x plus 10. It's x equal to 10. And now it's back to 10. See, it's 10. Similarly for y location, you can just make it y equal to 10. So now the x is in x is 10 and y is 10. So xy 10 10. Now I will just make it say add y equal to 40, and then now see 40 plus 10 50. So 10 50 is the new coordinate, and right now he is there, and what? Okay, so now I want to check the temperature. Okay, so for temperature we have to say, there was an example right just now, where was that, or I can check my code. So it is looking for get temp, so I can say get temp. So here I can just mention data equal to get temp, enter, and I'm expecting a value. Beginning loop, okay, get temp. Oh, I think this is coming here. You have to keep an eye over here. Get temp, see, get temp was 32, just scrolled up, and here we are not printing the value. Looks like I have to change the code here to make it print here, but as you can see, this is the temperature value it printed. So whenever you're asking, you're getting the value. So similarly, get pressure also I think I have, get pressure, and I can do that as well. And keep an eye over this place, get pressure, and oh, I think I hanged it, and that's the problem in Windows console. Actually not problem, it's good. I freezed it so that I can scroll up and get pressure, get pressure. So this was the moment or time when I called for get pressure. So yeah, that's what I wanted to show. Now the question you might have, how can I install ROS2 in Windows? See, it's a very I would say very hassle-free way of installing ROS2. You don't have Ubuntu, you don't have a Raspberry Pi, or you don't have a virtual box installed in your Windows, and you want to just simply test it. For that you can very well go to internet and find out anywhere, but anyway I have this GitHub where I'll be posting the things, and you can see how to initiate or how to install the or activate the WSL, and then install the Ubuntu, and then install further the Jazzy Jalisco. So all these informations are there, and also how to bind your USB and port forwarding, and then accessing from giving privilege to the user, and all these things is mentioned. So final thing, once you are done, you have to explicitly unbind it. If you don't do that, you cannot use the device from your Windows. So anytime you plug, unplug, you restart, whatever you do, you will not be able to recover the one from here. So what I will do, I'll just click on this unbind, and you see it will appear here. See, it's back here, but actually I want to bind one more time to show you one more thing. And we bind and attach, and this guy got killed, so I will just run it one more time just to show you one more thing, and that is, see, he's doing all this thing. And now in the meantime, just to prove that I am really getting it from the Arduino and not from anywhere else, I'll just press this button to reset the Arduino, and you see it closed, which means it is really coming from this hardware, and nowhere else. It's not a magic I'm doing. Okay, so thank you so much for watching this, and please let me know if you want any further video on ROS2. I would come up with, but I would definitely need your support and subscription, like, and sharing. Otherwise I cannot proceed with further helping you. And definitely I'm open to help in my WhatsApp, so please ping me in WhatsApp. I'll give you my WhatsApp link, and thank you so much. Bye.